Hi, Phil Whitehead here, and welcome back. This is video number 3 of our series, and today we're going to chat about studying real-world systems. We're going to add some complexity to these models that we're building, and I'm going to introduce to you a little bit more strongly the concept of simulation and why simulation. These are important to studying real-world systems, and as you finish this video, you'll begin to understand why, because I'm going to raise questions such as, how do I study a system as large as my enterprise or as large as my organization? It's not easy to do on a manual basis. It's hard to observe a total system physically. You can't just step back and watch all the elements of your organization work together. So this is about real-world solutions to real-world problems. Join me on the inside. As you saw in the previous video, studying simple systems or notional systems is one thing, but as you can imagine, studying a real-world system or business is quite another, and that's the subject of this video. As a matter of fact, we're going to take one methodology for the next several videos and explode those down to at least a modest level of detail to take you through how you can help manage change within your organization. And I'll tell you right up front, the more complex your organization is, the better this is going to sound. So let's jump in. What if we could increase throughput, decrease inventory, minimize operating expenses, reduce cycle time, and see the impact of policy decisions before they're made without investing in a final solution? And we can by building a simulation model. And that's going to be the subject of the next 3 or 4 videos. And so without further ado, let's get into this. You know, it's really amazing to think about it, because if you look at increasing throughput, decreasing inventory, decreasing operating expenses, reducing cycle time, etc., that's real world. That's what management or stockholders, depending on your perspective, is asking for. They don't want you to optimize throughput or optimize inventory or minimize operating expenses. They want it all. And they want it now. So how do you study a complex system other than building a model? So what is a model? A model is a representation of a group of objects or things or ideas in some form other than the real system itself. Now think about that. If I'm trying to study my business model, and let's say I have multiple sites, etc., 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 how do I do that within my lifetime? And so we build these models as a representation, not a duplication, of the real world system. So why do we use models? Well, I've already stated it. We use models because we want to learn something about the real system that we cannot observe or experiment on directly. And because the system doesn't exist, the system is too difficult to manipulate, it's too time-consuming. Think about it. Once again, how do I study my business? Well, you have to use models. And of course, it's too costly. It'd be virtually impossible to do it manually. Matter of fact, the time dimension alone, by the time you studied the entire system, various sundries and parts of it have already changed. So we must use models. We must use models. That's my opinion. So what is simulation? And that is defined as the process of designing a model of a real-world system and conducting experiments in the model to understand the behavior of the system and evaluating different strategies to improve or change the system. Again, the aspect of change management. And we can do this with simulation modeling quite efficiently, though it is somewhat time-consuming. So why use simulation? it provides a logical way of choosing among alternatives. What does management like? They like options. They like to know that you've done your homework when you're proposing change. Well, are there other ways of accomplishing the stated objective? And oftentimes with simulation, very often actually, we can build models that will provide choices that will identify problems before they occur, identify in the current state existing problems that maybe we did not understand. We can prevent that problem of making a change in one area only to have it pop up 50 operations later in another area. So these types of things can be managed. And as a matter of fact, it's the only way that we've been able to study these large complex systems with any degree of reliability other than guessing. By the way, that is an option. You can guess. And oh, by the way, if you haven't guessed already, no pun intended, about 99% of the people or businesses in the world do guess. And what do you get? Inefficiency, etc., etc. So we're going to use simulation because it provides a systematic, explicit, and efficient ways to focus judgment and intuition. This doesn't take away your experience level. It enhances it. It allows you to investigate areas that you would not otherwise identify. By looking at the total system, you can pick out areas that you want to study. And I'm going to take you through a case study in a couple more videos, and you'll see this was the only way to do it because the problems were complex, they were time sensitive, and almost impossible to observe other than by doing a model. Simulation helps to effectively communicate the system configuration and assist in the decision-making process. Well, think about it, change. When you're conducting a change exercise, what do you oftentimes get? And it's a people issue. You get resistance to change. We've always done it this way. That comes in various forms, but that's the bottom line. You can't change that because that's the way I've done things all my life. I was brought up on this system. This is the way things just work. They have to work this way. Well, why? Ask the 5 whys, and you sometimes can get a really, really different view of your current state. So simulation helps you focus and communicate these changes. And if you follow the strategy that we talk about, I'm going to add a couple bonus videos in the data collection, it becomes your stakeholders' model and not yours. So it's kind of cool. So why use simulation continued is very few real-world problems are free of random or unpredictable behavior. Now think about it. If you tried to do an optimized model, meaning there is one and only one optimal solution, well, you try to apply that in your business. Think about it. Can you predict with certainty that on day Y, person X is going to be absent, therefore affecting the business process C? Of course not. But using simulation and the power of statistics, we can reasonably predict that or accommodate that type of data into the model so it more closely reflects real-world conditions. Does that make sense? Simulation models capture the important random components of the system. That's what I basically just said. Absenteeism, variability in demand, etc. Time is an important component of simulation models. If you do a static model, which is like a flow chart, it describes behavior of a system at a moment in time, at a single point in time. And of course, things change during time. We have more or less absenteeism. If you're in the state of Pennsylvania, when deer season opens, you can pretty well be certain a lot of people will be on vacation or sick that day. That's just one example of things that can be identified and studied as you're building your as-is model. Simulation models are dynamic in the sense that they describe system behavior over time. I can change the time dimensions. For example, I could run 30 years worth of data in just a few hours and get a smoothing effect of change or the current state over time. And that takes out some of the randomness and statistical variability in systems. So this is just some ideas of why you want to use a simulation model to study your business. I'm hoping that this is making some sense. So it allows you to analyze large, complex problems for which analytical results are not available. How do you observe, once again, how do you observe your business if you wanted to take a total systems view of it? How do you do that in a time frame that's going to be meaningful? And the answer is oftentimes you cannot. You have to have a model that helps you gain these insights and identify areas that you want to explore or understand further. It allows the decision maker to experiment with different policies and scenarios without changing the real system. Think about that. How many ERP systems or scheduling systems have been purchased without a clue on how it's going to affect your current processes? We've all lived those nightmares. And now you can predict, not 100%, but within a certain amount of certainty, say 90, 95%, the effects of adding new processes to the existing system. It allows you to compress that time. I can run multiple years of data in just a few minutes or a few hours, and thereby smoothing out any statistical variability that may interject itself or will interject itself into any system. So you get a better reading for what's going on around you, especially in the current state. It requires little or no complex mathematics. It's easy to understand, in other words. Later in video 7, I'm going to teach you a couple of very simple manual techniques that you can use to simulate a simulation, if you will. The disadvantages of simulation: because the results of the simulation are based on a specific set of random numbers, the results are only estimates. The results are only estimates. Wow, that's a problem, isn't it? Not really. Think about it again. In your world, don't you have the absenteeism? Don't you have the material shortages that pop up somewhat at random? Yes, of course we do. We have all kinds of things and 1,000 other things I can't predict. But if I study the system through time, I can smooth some of those out and predict them. And that's a function of how I collect my data, by the way. And I'll get into that. To improve the estimates, we need to use a large number of trials and/or we must repeat the entire simulation many times. That's a fact. As a matter of fact, I will tell you this, that as you build your current, there's two types of models, the current state and the future state. The future state is actually quite easy. The current state model, you're going to spend a lot of time on because it needs to be a fair representation of your current business model. And so you need empirical data that will support when you're close enough. And so this will take a large number of trials. You're going to see strange things happen in your current state model that will require immediate investigation even to begin to understand. And so therefore that will cause you to repeat as you learn the simulation many times until you reach a steady state on the current state, if you will. So we need to run these simulations many times. It will cause you to investigate many different strange things you've never seen before in a model, but actually occur oftentimes in the real world. Each simulation must be specifically designed to mimic the scenario under investigation. So, for example, if you're trying to study a manufacturing system for the purpose of synchronizing it, then you need to pick on your manufacturing system. But you also need to look at your manufacturing system in context with your total system, once again. So, but once you pick an area to investigate, you'll drill down into a much greater detail oftentimes to really begin to understand the problem. So that's kind of an introduction to simulation modeling. I'm going to take you in the next video, in the interest of time, I'm going to split it into two, into the attributes of simulation. And once again, we would appreciate your feedback. If you'd like more data, more detail, etc., I imagine many of you would. This might just push us along to do a deep dive on particular subject matters. So get your request in, add your comments. We read them all, and we appreciate them all. Thanks so much.